Okay, I'm gonna shut off my radio. I don't want to get in trouble with the music police. Now, it took me 30 minutes to set this up, so let's hope this works. What we're going to do is begin to wire the tender. Now, excuse me, have some more coffee. Wire the engine, Lordy. Now the key with the engine is it has a motor, right? So it's going to need some power into that motor to make things turn. But in our case, we have some other stuff as well. So besides the motor, and I can look through here and see right away, one of my more favorite pieces is a smoke heater. Has 2 wires. The motor obviously has 2 wires. Another wire that's on here is the smoke generator fan motor, but it goes directly into a puff and chuff board, so that doesn't worry us. It's on here, but it's not external. If we look at what's external, these are external and these are external. Okay. Then we have our trigger. This is a gear turned by the motor that also turns the drive wheel, and this is a 1-to-1 ratio. And we have a sensor. Either it's triggered by a cam or a magnet, but we have a sensor here, and it has 2 wires. And it goes out to soundboard. Okay. The other piece that comes off on this gizmo here is a relay, and the relay has a pair of wires that come out as well. So we have the puff and chuff relay, we have the chuff trigger, we have a smoke heater, and we have the motor coming out. So we have 8 wires that need to come out or into the engine. And as we know, we've already made our connectors out here that we're going to plug into something, right? It's actually going to be a more loosely designed piece, but it's going to be 4 pins. Oops. And these pieces are going to go to this thing up here. Okay. For example, this is A, this is B, this is A, this is B. That's how the harness is going to hook up, okay? So, set that aside as our review. Now we want to look at the piece in detail and see how and where we have to mount. So the first thing I see here is a platform that I've put in, and this is what we're going to call the fireman's deck for now. And it has a pair of holes, and it goes up and it mounts onto the bottom of the motor. But what happens, it also has a hinge here, but as it happens, the wiring is going to come down through this hole, come out underneath, and it's going to end at some point on this piece. And it's going to end somewhere like here. And this is where the other plug is going to be. Okay? Underneath and then up. Okay, so if you look at it from the plan view, this thing is going to be underneath. These are going to go up like that. And these are going to go up like that. So the wiring is going to be coming up out of a hole. And here's the hole. Here's where the wires are going to be coming out of. So they're going to be coming up like this. Okay? And on this side, they'll be coming up this way. Okay? So when we look at, for example, if we start with smoke, we have the smoke board right there with 2 pins. And we know that smoke board is about 10 millimeters from the edge of the puff and chuff board. And the puff and chuff board is directly at the end of this piece, and that is about 4 millimeters hanging down. Now once it's under there, it has to go, is that 4? Yeah. 4? That doesn't sound right. About 30. Wow. 30 millimeters. I'm reading centimeters, not millimeters. So let's do this again, right? So this is 85 millimeters and 30 millimeters. Okay. Sorry. Okay. Then after that, it has to go out and then to a plug and terminate, and that is about another 20 millimeters. So 50, we add these up, 85, 30, and 20. And how I add is weird. I go easy first. So that's 105 and that's 30. So it's 135 length of wire that is going to go like this, then it's going to come down, then it's going to go out, and then it's going to get terminated to a pin. And that's the, oh, and there's 2 of them. Right? Positive, negative, volt DC. Okay. So this has to be 22 gauge. And that is my flexi wire, which I have plenty of. I have a roll of it. And it's going to be, I don't know, do we need a plug here? We can't have a plug here. It's soldered into the connector. So it runs up here. We don't really want too many joints, but it is smoke. It might be convenient. There are, on the board now, there are a pair of wires like this. So if you had a female 2-pin, right, that could work with the 22 gauge coming out. That could be a good way to do it. You could make one at, I don't know, 140. I don't want to waste wire, but you always like to have a little extra. You could make a 140, or you could do a test at 140 millimeters, and then put the, solder it to the pin and leave it for now. And maybe that's the best approach. Plus, we need to find out where these wires match on our connector. And we have to come up with an orientation and maintain that. So that's something else we're going to have to deal with. So this is just the smoke wire, okay? It's 140 something and maybe a connector, okay? So now as I look at this one again, I see the other one that comes out is the chuff trigger. And that's pretty easy. It's going to be sitting around that gear. We have a cam with a switch or a magnet, so one of those two. I think I'm going to go with the magnet. It seems to be working the best for me. And just above that is the puff and chuff board. And this trigger goes all the way down, so it might be just as easy to bring it to go down, down, and out. So as we look over here, we know, well, I get the measure and make sure I got it accurately. It's about, oh wow, it's about 75 millimeters to the switch. Then we know from our previous test it was 30 down and 20 over. Okay, so now we have 75, 30, and 20. So I got the 105 and 20 is a 125 millimeters this time. And this is it's a switch. It's a limit switch. It's very small. This is it right here. Now I had a connector in here. This has low power requirements. It's just a trigger. It's just a circuit, like a spark plug. You know, give me a spark. Okay. So we could use less gauge. In that case, we could use couplers like this to fasten it in. Maybe the plug could be back here. You know, put the plug here. So you go this way and that way. That way you could unplug this and remove the board, but you still would have, it would still be flippy floppy. You got to pull it out of the hole. I don't know. If it came down and goes forward, I don't think we want any plugs down here. I don't like that idea, because now you're down into where the trailing truck and the coupler connector and all that gets messy. I'd rather just have nice clean wire coming up, I think. So let's see. I won't say plenty of room, but there is some room here. I think I'm going to stick with it back here just because. The other thing why it could be back there is just around the corner is the smoke. So if we put that connector at that end, that might work out too. Put that connector in with 22 gauge, put this connector in with the 24 gauge. I think that makes good sense. We'll make it, it'll be fine. So we're going to use 24 gauge and we're going to use connector. So that's the chuff trigger. Okay, now the other one that we have that goes to the motor is, the puff and, that's a puff and chuff power. Now that power goes into the puff and chuff board somewhere like that. And of course that's going to go to this hole, and then it's going to go out, and then it's going to go to a connector. So we know we're going to have this 20, we're going to have this 30, it's still 30, but then whatever that length is, I'll tell you what that is right now. It's going to be 35 to 40. I think that'll be fine, 35, 40. So we'll go 35, 30, and 20. That's 5, carry 1. 3 and 3 is 6, 7, 8, 9. 98, 95 millimeters. Overall length, okay. And it's really soldered into a board right there. And then it goes down. And it needs to be the 22 gauge, because this is bringing in the main 6 to 7 volt DC power for the puff and chuff. So I want to make sure it doesn't have a problem with power. I'll think about this. This is the connector. Do you want a connector here or not? One way I could do that is to solder some pins that are like this, that are right angle. So if you look at them online, they look like this, these pins. They have a little plastic piece there. Solder that down. There's 2 of them back to back, and then make a socket that they would plug into sideways, as long as there's enough room on the side to do that, and then route the wire this way. That might work. There's not enough room to do them any other way. So you socket like this, plug it in, then run the wire that way. The wire lengths would all be the same. It's just, it might be a little shorter because of the thing. I think I'm going to try to do that. Let's do a test. We'll do a test on that and see what we get. Okay, so we got smoke, we got the chuff trigger, and we got the puff and chuff. Okay, the very last thing is the motor. Now, the motor has a little nuance. I'm going to start a new page because the motor has some nuance. With my system, this bleeding through, I've got pencils, but I think you can see this better, and I like drawing with it better anyway. Okay, so we're going to start with a motor, and it's sitting right there with the springs hanging out. That's always kind of fun. and the holes right there. Okay, well, I've already decided we're coming in here. We're going to go here to the connector. So we're going to come up, and we're going to come up, and we're going to come up above and then come down like this. That's how I want to do it. So when you look at the motor, it's going to look like that. And if that's rotated, whatever, this way, right. Okay, so it's going to come up and it's going to go like that. I want it to have a loop. I don't want these to be pulled or stressed in any way. Then it's going to go down the hole. So that's how the motor goes, and it goes to the plug. So that is going to be the connector for the motor, some length, and then it goes right to the plug. Okay, let's see. That is not going to be a lot of wire. I'm going to start by going up. I'm going to loop it up to, I'm going to say, okay, I'll draw it this way so you see everything. There's the puff and chuff board. There's the motor, there's the spring, so it's going to be right here. So it's going to start there to there, and it's about, from there to there is about 20. There is no real down, it's just on an angle, and that's about another 30 to the hole, and then another 20 to the connector. So 2, 4, 6, 8, 10. 100 millimeters. What? 2, 4, 5, 6, 7, 70. Good God, Dennis. Think about it. 70 millimeters. Okay, we got it now. Oh, Lord. Okay. And 2 times 2. All these times 2. Okay. Now the nuance is I have a puff and chuff trigger. I have a different, it's not a trigger, it's an on-off sensor. Okay. It's not really what it is. It's a motor on-off sensor. Okay. And it's sort of a goofy looking board with some diodes and a capacitor, and it has inputs for the motor input, and then it has outputs for this the motor on off. It actually goes to a relay, so I've been calling this the puff and chuff relay wiring, relay trigger or sensor. I don't know. It's a trigger, and it senses the motor, whether the motor's in forward or reverse. It's on. That means the same thing to this circuit. And when the motor is on or off, that changes the function inside the puff and chuff. If the motor is on, then we're doing what's called puff and brake. If the motor is off, then we're going to do idle. And this is for the fan motor controller. The puff and chuff relay directs the fan motor controller, which is on puff and chuff board. So I need to know if the motor's on or off. If it's on, we're doing puff and brake. If it's off, we're doing, if it's off, then we move over to idle. It's either or. And at idle, you get lazy smoke coming out. At puff and chuff, you get puff, puff, puff. You get pulses of puff. Here it's a stream. That's the difference. Idle is a stream, puff and chuff is a pulse. So now I got to put this board in this circuit. Oh, now I've messed up all my paper. All right. Well, I told you this was going to be complicated. All right. So the trick, I think, the way to do it, I'm going to mount this board on top of the puff and chuff with some sticky tape. It has 2 leads that go to the motor. We've said the motor controller is going to come down like this, and it's going to come up like this. I really don't want to cut these lines. I just don't want to add another break. What I think I'm going to do is take these wires, and I'm going to pull back the insulation. I'm not going to cut the wire, but I'm just going to pull the insulation back, and I'm going to wrap a wire around the uninsulated wire and run that wire to the board. I'm going to do that in both of those wires this way. Because what I want is the sense of the motor status. I don't want much energy, I don't need much power, I just want to know, is the motor running or not? And that's how I'm going to do it. And so these wires will have a little break, and then a piece of wire coming out, and then I'll cover it up with tape. That's how I think I'm going to do it. So these wires are only going to be well, that's true. If you look at where they plug in to the board and then to the motor, from here to here is going to be 40 millimeters. That wire. So that's going to be a fixed wire. Then from the motor to the motor to the sensor, it's going to be that's not 40. It's not to worry about. Okay. Then it's going to come down. It's going to probably come down about 20 millimeters to this motor. Then the motor wire we have figured out. So now this is probably going to be another 20. So the wiring for this particular board is going to be a pair of 30 millimeters to the board, and that could be a plug. This does not need power. This is low power, so this could be 24, maybe 26 gauge. It's okay. Then the same here. These go right down, so these are going to be 20, and they're going to be tied in, and you're definitely going to want to unplug those if you can. So it might be good that we put a socket in here somewhere, and that could be a 24 gauge, 24 gauge socket. I have those 2 wires. If this is socketed, this could be hardwired, I think, for continuity. That's okay. So maybe we just have a socket over here, and this is the relay trigger. Okay, so that's the relay wiring. So it's going to be 2 wires, 30 and 20, and it's going to be sitting right here. Here's the board. So I'll rework this probably. These 2 wires will just go right back to here. These last 2 on the board, that's all they have to do. And then these are just going to reach over and go right into the motor wires, tap into the motor wires. And then that's going to be stuck down with sticky tape right there. Okay, so this is the relay trigger. Okay, got it. So that's the plan. That's what we have to do, and I'm going to get started with that momentarily. I'm going to send you this so you can chew on that. I'm not good at cutting and pasting video, so I haven't taken the time to be good at it, so I'm not. And Wanted to let you know what the game plan is. All right, so we're going to put in these wires, and then I'm going to probably leave them empty. I have the connectors that I need built up. These are 4 pins. I'm soldering to the short pin, and then the long pin will plug into the socket that's on the tender. You always want the powered end of any harness to be no pins, so you can't just touch things, like drop it and touch it and get electrocuted. I know these are trained, right? 5 volts, what? But still, you don't want to burn up your system. So that's just the way it is. And so I need to get my map figured out for that, and make sure if I'm dealing with which wire it goes to which pin, and if I plug it into that socket, the orientation, right? You can plug it in a couple of ways. So I got to make sure I'm going to put a mark on one side, probably paint it with something like white, so you can see this is the white side here, and this is the white side here. So you line those up and sock them in, and they're fine. That's how you do that. Okay, that's it. I'm going to shut this off, send it, and then I'll go to work and come back, and hopefully you'll see the end result. We hope. If I have time. I don't get distracted.